Hello, students of grade 9. This week we have a mathematics lecture. It's lecture 3. We are continuing what we started last week in our lesson, algebraic expressions or polynomials. So this is part 2 of our lesson. And this part, we have seen it last year. And now when we start talking about it. So first I'll start with the objectives. Number 1, how can we solve a second degree equation, which we call a product equation? Number 2, as a reminder, I will give you a solved exercise. Number 3, define a fractional expression. Number 4, how can we find the domain of definition of a fractional or a rational algebraic expression? Number 5, simplify a rational or fractional algebraic expression. Number 6, solve a rational or a fractional algebraic expression. So rational or fractional expression, it is the same. So we will start with objective number 1. Solve a second degree equation, which we call a product equation. What are the forms of a product equation? First, when we talk about a product in math, it is two things multiplied together. So here in this equation, we are solving an equation where two things are multiplied together, and in the second side, we always have the equation equal to 0. So as all the equations we talked about, the product equation has two sides. On side 1, we might be multiplying a monomial ax by a binomial bx plus c. So a monomial times a binomial, and on the second side, it will be equal to 0. Equation form number 2, we might have on side 1 two binomials multiplied together equal to a 0 on the second side. As an example, I will give you an example on the first one. So if we are given an equation to solve, it might be a first degree or a second degree equation. So to solve a first degree equation, what do we mean by a first degree equation where the exponent of the variable x is 1? We make it in the simple form, how all x to side 1 and all numbers to side 2. A second degree equation, side 1 should be in factorized form and side 2 should always be 0. So if you look here at these two examples, as I'm saying, this is a second degree equation, so side 1 should be in factorized form. This form is the first one, a monomial multiplied by a binomial equal to 0. How can we solve it? So either 2x is equal to 0, then x is equal to 0, or x minus 3 is equal to 0, then x is equal to 3. Always a product equation or a second degree equation has two solutions, and I put my solutions inside a box. The second form, where we have a binomial multiplied by a binomial equal to 0, so this is a product equation equal to 0. So I say x, here we have x plus 3. So let me write this in my example. It's not x plus 2, let it be x plus 3. So we have x plus 3 into 2x minus 4 is equal to 0. So either the first binomial x plus 3 is equal to 0, then x is equal to minus 3, or 2x, let it be plus 4, or 2x plus 4 is equal to 0, then 2x is equal to minus 4, x is equal to minus 4 over 2, then x is equal to minus 2, so it has two solutions. So as I said, let us solve this first degree equation. 2x plus 3 is equal to plus 7 is equal to minus 3, since the exponent of x is 1. So this is a first degree equation. 2x is equal to minus 3 minus 7. I'm making it simple. So 2x is equal to minus 10. X is equal to minus 10 over 2. Then x is equal to minus 5. 3x squared minus 5x is equal to 0. As you can see, the degree of x is 2. Then this is a second degree equation. So I should factorize the first side. There is a common factor, which is x. So we take x. 3x squared over x, it gives me 3x, minus 5x over x, it gives me 5 is equal to 0. So x is equal to 0 is the first solution, or 3x minus 5 is equal to 0. Then 3x is equal to 5, x is equal to 5 over 3. A second example, x squared minus 25 is equal to 0. Here also side 1 should be factorized. There is no common factor between the terms. So I factorize it using remarkable identity 3. A squared minus b squared is equal to a minus b, x minus 5 into a plus b, x plus 5 is equal to 0. So each of the two binomials is equal to 0 and we solve. Or we can have x squared minus 6x equal minus 9. This is a second degree equation. And as I said, always the second side should be 0. So to make it 0, we take the minus 9 to first side. It becomes plus 9 equal to 0. Now we factorize side 1 using the second remarkable identity, since we do not have any common factor between the terms. X minus 3 squared is equal to 0. Here we take it as a double solution, so x is equal to 3. As I said, as a note, a second degree equation always has two solutions or two roots. Please apply these examples to understand them more. Now I move on to the second slide. As a reminder, I have given you now a solved exercise. I have solved this exercise. Always you can practice this exercise by yourselves on a draft. It is solved. Now I will start talking about rational. Let me erase this. Written here on the slide. Okay, so now we will start talking about rational or fractional expressions. As their name says, it is a fractional expression. What do we mean by fractional or algebraic, fractional or rational algebraic expression? By definition, it is an expression written as a fraction where the numerator is a polynomial and the denominator is a polynomial. So in a fractional algebraic expression, in the numerator we have a polynomial p of x, and in the denominator we have a polynomial q of x. So this is how a fractional expression looks. F of x equal p of x over q of x. Now we will be solving a rational algebraic expression. To solve a fractional or a rational expression, we should always make sure that our denominator is written in factorized form. So always whenever you are given a fractional expression, the denominator should be factorized. Always we start with writing the domain of definition. Domain of definition means a fractional expression exists or is defined if its denominator is different from 0. As we all know in math, any fraction exists if the denominator is different from 0. So now let me give you two polynomials. P of x equal to x minus 5 into x plus 4. This is in factorized form. Q of x equal x plus 4 into x minus 3. This is in factorized form. I asked you, let a of x equal p of x over q of x. Now in a of x, I replace p of x by its factorized answer, and I replace q of x by the factorized answer, so I get this form. So this is the form of a of x. Now I look at my denominator in the fractional expression. X plus 4 into x minus 3, it is a product of two binomials, so it is factorized. Now we start writing the domain of definition of this fractional expression. We say a of x is defined or it exists if whatever I have in the denominator should be different from 0. So x plus 4 into x minus 3 is different from 0. Then x plus 4 should be different from 0. Then x is different from minus 4. And x minus 3 should be different from 0. Then x is different from 3. Now, after writing the domain of definition, now we can simplify a fractional expression. A fractional expression can be reduced or simplified only after the domain of definition is written. How? We cancel the like terms from both numerator and denominator. If we go back to a of x, which is this fractional expression, we can see that in the numerator we have binomial x plus 4. In the denominator we have x plus 4 as a binomial. So x plus 4 cancels x plus 4, and I get the answer 2x minus 5 over x minus 3. Now, how we solve a rational expression? I will follow the steps. Always we should start writing the domain of definition of the rational expression. We reduce or simplify the expression. We cancel the like terms from the numerator and the denominator. Now, number 3, we start solving. Now we will solve an example. We go back to a of x. A of x equal 4. Then I take the simplified form of a of x equal to 4. Here I have a fraction, and on the second side I have 4. So I change 4 into a fraction over 1, and I make the cross multiplication. Numerator times denominator equal denominator times the numerator. So I get 2x minus 5 times 1 is 2x minus 5 equal 4 into x minus 3. So this is a first degree equation. I solve it and I find the solution x. Now I have given you also a solved exercise to practice everything I've talked about. You should develop and reduce, you should factorize, you should write a fractional expression, domain of definition, calculate a numerical value, simplify, and solve. So this is a complete solved exercise. Also, please practice this exercise alone again on draft and compare your answers to my answers on the slides here. Now I want to remind you of areas or surfaces. We call areas, it is the inside space in any geometrical shape in math. So when I talk about a geometrical shape square, so the space inside the shape, it is called the area. Also in the rectangle, this is called the area. The parallelogram has also an area. The triangle has an area. The trapezoid has an area, and the circle has an area. I want you all to memorize these areas because we use them in our exercises. The area of the square is equal to s square, which means the side square. The area of the rectangle is length times width, L times W. Parallelogram, it is B times H, which is the base times the height. The area of the triangle, it is B times H over 2, which is base times height over 2. The area of the trapezoid is A plus B. What do we mean by A plus B? A is the big base plus B the small base times height over 2. The area of the circle is pi times r square. Pi is a 3.14 and r is the radius of the circle. Now there is a relation between algebraic expression and areas. We might be given a shape or many shapes together, and we have to find the areas of these shapes as algebraic expressions. For example, we are given this figure here. He is telling me in the given ABCD is a square. So ABCD is a square. Of side, the 3x minus 4. As you can see, the side of the square is given as a binomial 3x minus 4. We are given DE, it is equal to 2x minus 2, where x is greater than 4 over 3. Number 1, prove that the area of A of x, which is the trapezoid ABCE, I want to prove that the area of this shape is equal to this form. Okay, if I look again at the figure, I have a square and part of it is a triangle. So the area of the trapezoid is the area of the square minus the area of the triangle. So first I calculate the area of the square ABCD, which is equal to S square, which is a 3x minus 4 in parentheses, all of it square. Now I will calculate the area of the triangle ADE. This is a side of the square, which is the height times the base over 2, because this is the area of the square. So I multiply 3x minus 4 into 2x minus 2 over 2. Now 2x minus 2, I can factorize it. I can take a common factor 2. So 2 in the numerator cancels 2 in the denominator. So this is the area of the triangle. Now the area of the trapezoid is the area of the square, which is a 3x minus 4 square, minus the area of the triangle. So I write the answer. So we have written it as this form. Now I should develop and reduce a of x. We get rid of this parenthesis by applying remarkable identity 2. We get rid of these parentheses by multiplying all for all. Now we should calculate a of 1 plus radical 2. After we get the developed form, we replace each x in the developed or reduced form by 1 plus radical 2. And finally, to factorize a of x, I take a common factor binomial 3x minus 4, and this is the solution of the exercise. So please watch this video well, and if you have any question, you can ask me and I'm ready to answer all your concerns. Thank you and goodbye.